developer advocate at Google, and this is pretty much what I do most of the time. So I come out and talk to people about what's happening in HTML5, JavaScript, and the web browser land. And I'm also lucky enough to work on a couple of, one spec in particular, the web intent spec. But that's kind of cool, right? But we're going to talk today about what's new in HTML5 media. The interesting thing about this is that quite a lot of this is literally just landing in Chrome right now. So some of this isn't usable. Some of this is mainly in the dev channel or the Canary channel of Chrome. We're hoping that some of these things come to other browsers as well at the same time. But before I start, I would like to show you one thing. It's a plug. We're trying this idea of HTML5 Search. This is just a Google custom search engine, but the idea is that you're looking for kind of information on the section, article, or canvas. You normally get a whole load of extra resources that you don't quite like. This just indexes things like the W3C spec, HTML5 rocks, a couple of the best kind of HTML5 resources out there. So I'm going to encourage you to tell me which are the kind of the sites that you learn from the most, preferably not W3 School. Is anyone from W3 Schools here? No, good. Preferably not from those kind of sites. The theory about this is it's all on GitHub. So if you want to make a change, you put it on GitHub. I'll pull the change back in, and then we're going to make the kind of the HTML5 learning space a little bit better for everyone else. But that's HTML5search.com. That's the site that I set up quickly. But let's get into the media side of things. So HTML5 media, most people know that to be generally the video tag or the audio tag. But actually, it's quite a little bit more, and hopefully I'm going to show you some of the stuff today. There's a legend that goes along with some of these slides. The thing that looks like a radar means it's not quite ready yet, but it's going to be there soon. The bug means there is a bug for it. It's going to be tracked in WebKit. Hopefully, it will come to different types of devices, whether it's Chrome, Safari, iPad, those type of things. Things like the bug has been resolved or fixed. You're not going to see in many of them, actually. And then sometimes you've got things like specification links. I will share the URL at the end of this so that you can actually try some of the demos. There's a whole lot of inline demos with this talk. So this is me. If you have any questions during the presentation, just shout them out. If you have any questions after and you don't manage to see me or something, catch me on Google Plus or Twitter. Yeah, just email me as well, paulkinlan@google.com. Yeah, we're going to talk about multimedia capture, WebRTC. Did anyone see the announcement for WebRTC yesterday, I think, on Chrome? I did have a demo for you, but I can't show it because Eric, who was supposed to be doing this talk, didn't send me the server. But you're going to have to imagine that it's like the best demo ever, so it's kind of cool. And then the WebAudio API. So I just want to ask everyone, has anyone used any of these APIs at all in production code? Like WebAudio? No? So actually this is going to be kind of new for most people, which is kind of cool. So the multimedia helpers, right? So the first thing that we've got, and this mainly is for interacting with the canvas and WebGL. I think a while ago there was like a security issue with content pulled in across the web into WebGL because it would get access to your actual GPU. So they introduced this idea of a cross-origin specification into the image tag so that you could basically say, I trust these certain images on the web to be loaded in, put onto Canvas, and then I can extract the data back out of Canvas. Because the important thing to remember about the Canvas API is that it's tainted. So if you load an image from inside your domain into the Canvas, you can manipulate the data, you can pull the data back out and kind of do whatever you want with that data that's on that Canvas element. If any cross-origin data comes in from another website into your Canvas, which you can do, you can load a remote image into your HTML canvas, you can't pull any of the data out. You can't do this toData URL. The toData URL is a base 64 encoded string of the image. But now you can. So the idea is that we want to be able to safely pull image data in across the web from different domains, manipulate it in the canvas element, and then pull that back out so that we can save it maybe back to our server. So the first thing that we're going to talk about is this whole cross-origin element. This is the code. It looks very much exactly like the normal code for Canvas, apart from we say cross-origin, anonymous, or you can say use credentials. And then you can load the data in from the site. There's a couple of HTTP things you need to do, but it's not that bad. This is a demo. It's not the greatest demo, but hopefully it'll show you what it means. With no cross-origin, we get a security exception. So we've loaded some data onto a canvas. We're trying to pull that data out, and normally what happens is you get a DOM exception, which means that you can't actually, basically it's saying you can't get access to that data. And that's just a normal image on the same domain. And this is the cross origin. So we pulled that data in from the web. If we click this link, view data URL, right, and we show you here, this is showing you the actual full URL, the base 64 encoded data. It's not the greatest demo, but this is the data that specifies that image after it's been pulled back out of Canvas. So we've pulled data from one remote web service, pushed it into our Canvas, and then we've been able to pull that back out. It's kind of nice if you're trying to do anything with graphical manipulation and loading data through. It just means you don't have to proxy the kind of the remote image through your own server and push it back in. It's kind of cool. The next, has anyone seen the page visibility? Yep.
Server setup that's required for that?
Sometimes there is. Sometimes you have to put a little HTTP header in that just basically says, yeah, about the access control, and then it pulls it back in. Yeah, it's not on kind of any of our services at the moment, but we're trying to push to make that happen. The interesting thing as well, has anyone seen the page visibility API? Now this is kind of one person. Way cool. So the page visibility API is basically an API that tells you, as in you as the developer inside your page, whether the user is actually looking at that page or not, whether they've got that in their tab. And it's simple event. It's visibility change event, and then you can detect whether basically the tab is visible or it's invisible. The demo that we have is a kind of nice demo by one of my colleagues. Hoping this works. Page visibility. So cool, playing. Right, listen, you can hear the audio in the background. If we flick tabs, the audio stops. And that's because basically the code inside that page says, don't play the audio or don't play the video whilst the user's not watching that, not actually on that tab. We jump back, you notice the title in the top corner here. We zoom in. It's 7 seconds. We jump back and it continues playing. And that's all because we've got the ability to actually detect whether the developer, or whether the user is actually on that page or not. So it's kind of nice. I mean, I can imagine kind of advertisers trying to use this thing to say, well, you're not actually on the page looking at my advert, so I'm not going to play you the rest of the clip until you come back to the page. So it's kind of it's not a great API in that context, but you as a developer, you can do things like, if you look, for instance, if you look at a whole lot of the games in the Chrome Web Store, you'll notice that they play audio when you're playing the game. If you move tab, it stops the audio. That's because they've been able to detect that the user is no longer on that page and pause the game. It's kind of a nice API in that sense. RequestAnimationFrame is another one. It's kind of important, this, because this is used for animations, right? That's the main thing about this. And you can combine it in with the page request API. But the interesting thing about this is that you actually ask the browser to schedule an update for when the next kind of frame should be rendered, which is different from set timeout. Set timeout basically says, I need you to try and execute this function every 60th of a second or every 10 milliseconds. And the request animation frame is much more like, well, I'm going to ask you to render the frame, as in I'm going to ask the browser to render kind of my next piece of logic, my next kind of drawing command, and then let the browser decide when it should do that. The interesting thing about this is that because you're asking the browser to do the work, it knows a whole lot of things that you don't know about the machine. For instance, like the refresh rate of the monitor. So it'll try and lock the number of times that it can call your callback to, say, 60 frames a second. So if you're doing a game, this is kind of important, right? So you want to lock your game to the vertical refresh rate of the actual monitor. And you can do that with the request animation frame. The other interesting thing as well is that it's like, it can act like the page visibility API. So when you're not actually looking at the page, it can say, well, you know, the user is not actually looking at that page. I'm not going to schedule the next callback to actually render the next frame until the user is back on that tab. So it's a nice little API. It's a lot better than set timeout, and it's kind of locked to about 60 frames a second. We have a demo. Again, it's not the greatest demo in the world, but if we go here, you know, about 11 milliseconds per request, and that's because we've said, you know, every 10 milliseconds, you know, call the callback, do the draw function. We use this new hotness, which is the request animation frame. Wow, okay. So I don't know why it's on my one, but it's locked to 30 frames a second. That's because the browser is basically saying, you know, you only need to do the update 30 times a second, which is completely different to this, to the first version. It's kind of interesting. Normally when I run this demo, it's 60 frames a second, but today it's gone crazy, about 30 times a second. So it's kind of interesting. The media fragments, this is actually brand new. So the media fragments API, and you probably see this in YouTube where you can specify like a range of when the video should start playing. Basically, there's an API that's a standard kind of interface for you to specify what range the video should start playing for the user when they actually load your page with a video element in. So if you look, can everyone see this code? I know it's a bit small. Do you want me to zoom in? So if you look at the very top one, it says t equals 10, 20. That basically means just play the video from 10 seconds to the 20th second. Not three, but right, this is going to sound silly, right? So when you say in America through 20, does that mean 10 to 20? Yeah, sorry, that's fine, right? Because it's different in the UK. So this is pretty much new. It's a nice way of kind of just specifying like indexed points inside a video. We never really had that before. To do this kind of thing, you had to try and move with a piece of JavaScript 10 seconds into the video when the page loaded. It's kind of nice. It says it's implemented in Firefox. It's in the WebKit nightlies. Pretty much if it's in a WebKit nightly, it'll be in Chrome Canary. Actually, I want to ask a question. So who uses Chrome? Quite a few people, good, sweet. Who uses Chrome beta channel? A couple of people. Dev channel? 2, 3, 4. Canary? Ah, cool. So Canary is kind of cool because Canary basically is built, I think, about every 60, 70 commits. I'm not exactly too sure. But you're pretty much getting the latest code that's been committed into our repository that's deployed just say it's every day. So basically you're getting a new update every day of the latest version of Chrome. So you get to test a whole load of these things. There's a whole load of kind of APIs that we're talking about now, which we haven't enabled in the dev channel. The dev channel is about once a week update. So if you really want to test some of these things out, the Canary channel is a good one. One of these things in particular is the track element. So the track element is, it's like subtitles, but actually the easiest way to say is it's subtitles. You can specify a VTT file, which is basically this file here, which tells the browser, if we zoom in, which basically tells the browser when to play, when to put some text next to a video. So you have like time offsets. So this is the first half a second to the second second. It basically just says, it'll say the web is always changing. This is great for accessibility. Before this came out, videos weren't really that accessible to people who couldn't actually watch the video because they have visual impairment. So I will show you the demo. Let's have a look. Sorry.
The web is always changing, and the way we access it is changing. The source of that change is here.
So that's, I mean, it's not the greatest kind of sexiest demo, but this is actually a big step forward for accessibility. We have the ability to put these subtitles in the video and let people do stuff with that. It's actually kind of nice.
Screen readers have access.
Screen readers, yeah, well, it depends on the screen reader, right? The screen reader has to make sure that they can parse this. I did actually say visual impairment. People with a visual impairment can do that. That's wrong because they won't be able to read the text. Hearing impairment. So if you can't hear the video, you can actually see what's happening there. Yep.
What's the version of Chrome that supports this?
I will tell you. So at least 18 Canary. It's probably a couple of versions back as well. When I say versions, Canary builds back. I'm told this will land in the dev channel pretty soon if it's not already in there. But essentially this is a track element. It's a HTML element. You can specify the language it's in, so you can localize the content based off the user's language. But it's kind of cool, right? It's basic, quite simple. The really interesting thing is actually the API has a JavaScript, or the element and the kind of the API behind it is a JavaScript API. And the thing behind this is basically it says every time the queue, which is the piece of text we saw in the previous slide, every time that changes, the browser's detected when it should change, you can get an event. Which means that you can do some really nice demos, which I hope is this one. Yeah. We don't need the sound, but this is kind of interesting because if you notice, it's not the same track element which is across the top. The interesting thing about this, if we jump into DevTools, let me just get. So the really cool thing about this is, I mean, just zoom in because it's hard to see, is that because we've got the on change event happening, we can update the DOM. So that we're updating the DOM, and because we can update the DOM means we can do some nice styling for it as well. It's a very basic effect, but it looks kind of nice and it looks really good. The JavaScript is here. It's actually quite simple. The track on queue change, and then basically we look at the actual individual queue, and then we insert it into the DOM, and then we can style it up from there. It's really simple. It's really simple. It's kind of nice. Let me just jump to the next one. Here we go. So the theory behind this is, yes, yes, sure.
Last time I checked this, you have to set up your server to serve the right line type for BTT files. Is that still
I think that is still the case. Actually, no, it's not the case because this is on my own personal server and I've not set up the MIME type. That's a good question. So has anyone ever used app cache?
Yeah, the same thing.
Yeah, so apparently we've got rid of that from the spec as well. But yeah, so it just basically reads it in. So you ask for the app cache. I believe it's a similar thing because, I mean, app cache, if you've ever done any offline work with HTML5, app cache is a nightmare, not only because the format is a bit, well, it's a bit different to the way web developers normally work, but you had to serve it with a very specific MIME type. And that caused so many developer pains as well. And I didn't realize that you had to serve this one with a different MIME type. I don't, and it still works.
Is that kernel or is that standard?
I would have to check. I would have to check. I've not read the standard on this one. But yeah, I expect that Chrome tries to follow the spec, because unfortunately our implementation at the time of app cache still requires the actual thing, even though it's gone. So hoping we're going to remove that soon. So the media source API streaming is kind of interesting. The whole idea behind this API is you can say to a video where the data source comes from. Normally, traditionally, the data source is a URL, so it's some file on a server, which the browser will then go and pull in. The media source API is brand new. The whole idea behind this is that you can actually specify how you want data to be loaded into the video element. So the theory behind this actually is that you could say, well, we want to do some basic kind of quality of service kind of rendering. We'll have 3 or 4 different types of quality of video: high quality video, medium quality, and low quality video. You would then go and fetch the kind of the source block, so like a frame or a couple of seconds of data from the server via an XML HTTP request, and then append that data from the XML HTTP request into the video. And it's a very basic idea of kind of adaptive streaming, but the idea behind it is if you recognize that the network connection is getting slower, you can then swap to the medium quality, and then between the medium quality to the lower quality. But the problem behind this is it's very much up to you as the developer to control how the data is loaded in. So you don't have to use a traditional URL. You can basically say, well, I'm going to load the data in from a set of XML HTTP requests or whatever you want. It's in WebKit. Yeah, we haven't got a demo for it in this one. It's in WebKit. I'll tweet about some of the demos actually, because we have got some nice demos for this. Actually, on the next slide. This is the code. You have to specify the source is WebKit media source URL. That just basically tells the browser to switch into kind of dynamic data load rather than just a normal load. And basically you get this WebKit source. Again, it's WebKit prefix, so it is only available in WebKit at the moment. WebKit source open event, and then you can start sending data to it. So basically in this one, we're passing through the source append method on the video element, we're passing a typed array, which is basically a byte buffer. And then you can start to kind of keep passing that data in. It's kind of nice. But it's nice. I think there's a very small set of use cases for it, but it's one of those things that you can be aware of because you can start to do some really cool stuff with that. I have seen people try to use binary WebSockets, because binary WebSockets are kind of pretty new in the spec, and I don't think I'm covering them today. But the idea behind binary WebSockets is that you can start pushing data to people through the WebSocket interface and then start appending that to the end of the video. So there's some nice things that you can do with that as well from the kind of the push side of things. This is the demo to break file into chunks. This is actually a really hard demo to show off because, there we go. All it does is it shows the video playing, which is the desired effect is a video plays and it plays as expected. But the interesting thing here is that the actual video is broken down into different chunks, 5 different chunks, and then we've just loaded them on by appending it to the end of the data source each time. And that's because we have raw access to the data. And I'll tweet these URLs at the end. Has anyone, I think a lot of people have seen this demonstration. Has anyone seen the speech API? Do you want me to give it a go? See what it's like? So the whole idea behind this is obviously there's multiple different ways that you can put data into a text box. It's through a keyboard. Well, normally it's through a keyboard, right? Or kind of a touch sensitive screen. The idea behind this is x-WebKit speech. That's the only attribute that you have to know. It basically puts this little microphone on the screen. Hello, my name is Paul. Whoa. Yeah, that's. You
need to get the English version of that.
It's yeah. I flip an heck. I know some people pronounce my name different, but it's not that bad, right? Bob. Okay, so this is actually a good. Sorry?
I thought he was your uncle.
I have actually got an uncle, Robert, but anyway, doesn't matter. I haven't. I'm joking. If any of my family see that, they'll go, no, you haven't. I've got a friend called Bob. So the whole idea behind this is actually there can be errors in the quality of how, the data it returns. And the interesting thing about this API is that, if you don't want to listen to the data, the actual on-speech change event, it's just going to put the text into the kind of the text box. But you want to look for WebKit speech change because actually what it does, it gives you a range of values, like the value it thinks that you said and then the associated confidence. The confidence value of 1 means it's like, we think that you pretty much definitely said what you said. And in this case, if we look in here, that's cool. It thought, hello, my name is Bob, was 83% likely, which is kind of right? I didn't say exactly what it said. Hello, my name is Ben. Well, that's my son's name. Hello, my name is Earl. That's kind of odd, right? But anyway, basically it said there's 0 confidence with this. I actually think this is a bug because it shouldn't actually list anything if there's 0 confidence. But that's it, right? You can actually get a list of different things that the speech engine behind the scenes thought that you actually said. So you cannot, the idea behind this, right, is if there is a kind of non-keyboard way of actually doing the input, you can actually let the user select the different values if they think it's not exactly right. So it's kind of nice. Camera. What is the browser support? At the moment, it's pretty much Chrome. It's hyphenated. It's prefixed with the WebKit version. But I don't think WebKit itself, that's the Safari and the kind of the iOS Safari support it. Sorry? Yeah, there should be. I've done it. So, into the cloud. I believe it's on some servers. Maybe. I think if it's Chrome, right, it's pretty much likely. The reason why I'm saying that is because I don't exactly know. But there's Android functionality that's quite similar. It's the same. I presume if it's not the same type of infrastructure, it'd be odd, right? Actually, this is kind of cool. So microphone and camera access. This is literally starting to land right now. And I'm hoping my build of Chrome is not broken because we have a demo. But this is kind of cool, right? Because we've never had the ability to interact with video cameras without resorting to Silverlight or Flash or other kind of plugins. And what we're trying to say today is actually you should just be able to do that inside the browser, and the browser should let you interact with the microphone and the camera. The API is kind of pretty simple. It's called navigator.getUserMedia. You specify whether, well, this has changed actually over the last couple of days. You specify that you want audio and video. You can say true or false for both. I don't know why you'd want to have false for audio and false for video at the same time, but it might be possible, right? But essentially, it returns a stream out from, once the user has accepted the fact that you can access the camera from your website or your web application, it returns a stream. So this is actually an asynchronous API. And once you get access to that stream, you just basically go window.url, create object URL with the stream, and then it attaches your video camera or your audio, your microphone to the audio elements if you want, straight to the source. And I'm going to show you what that looks like now. Here we go, basic demo. So I did make sure this worked. My Mac is slow. It doesn't turn the camera on properly. I'll just wait for, hey, cool, here we go. Whoa, it's got like an effect going at the back. But this is the webcam access, right? Hello everyone. It's kind of cool. I'll show you the code just so we prove what it is actually a video element. The video element, it's got a blob URI, which is basically it's a URI that prefixes the domain and then some just extra, extra GUID information at the end. But this is access to the video camera, and we can do some really nice things with that then. So this is literally landed in Chrome right now. You have to enable it with a prefix, which I believe is, yes, sorry. Is there a speaker API? So which speaker you're sending the audio through? No, but that's actually a nice API. So there's some stuff with the WebAudio where we can do some extra stuff, but we can't direct which speaker that you want to send it through to. At the moment, you have to manage that through the actual system preferences yourself. So anyway, this is the video element. It's kind of cool. This is the very basic one. I want to see if there's a demo that I can show you, which is really, really nice. So there's a bug on my machine is the video camera never turns off. This is how, it's kind of crazy now. But let's give it a go. Explode video. Oh, cool, so it's still working. Then because it's on a canvas, we can do some really nice things. And if I wave, it's still doing all the stuff. So this is actually really nice. This Explode demo is quite old. It's been around for Canvas, kind of showing you how to interact with the video element and Canvas. The reason why this works is because we've attached the video camera data source to the video element, and then because it's on the video element, then we can do those same type of processing effects. It's really nice, and we don't suffer, in this case at least anyway, we don't suffer from kind of cross-origin issues because the blob is prefixed with the name of the domain, which means that we can do some nice things with Canvas. So that's pretty cool. And I know 2 of those demos don't work because they crashed on me earlier on. So that's kind of interesting, right? You can do some nice stuff with the camera, put up to the video, provide some nice effects. But actually, normally what you want to be able to do is either record that to a stream, maybe send it back to your server, or do something else kind of more interesting with it, like WebRTC. Without having WebRTC in place, and we haven't got a demo for this either because it's not quite ready yet, is the ability to take your data from, excuse me, take your data from the media stream, which is that thing that's returned back from the get, which is returned, let me jump back to, the S, this is the stream, the function that's, or the data, the value that's returned from the get user media call. You can basically say record. That's the whole theory behind this. It's pretty simple. Is I want to start recording the data that's coming from the camera. The theory is as well it should be able to do audio. You say stop, so stop recording here, and then once you've got access to the data, the recorder object, which we set up here earlier on, you can actually say get me access to the recorded data. Excuse me. Once you have access to the recorded data, you could probably do a lot of things on the client with it. You might be able to kind of analyze the frames. The easiest thing in the kind of the basic demo that we say to do is you just upload that to the server, your server, and then you've got the user's video camera access. So you've got the user's kind of the video data that they've just sent to you. You push up to the server, and you can do whatever you want with it there. So it's kind of nice, right? It's kind of cool. People are going to obviously use this for doing things like taking profile photos and all that type of stuff. So it's going to be pretty cool.
What's the footage that you use in the video?
I wouldn't be surprised if it was WebM in this case. The theory is it's kind of agnostic to the platform, but you've got to expect it on the other end, and I wouldn't be surprised if it was WebM. That's not to say it is, but I've seen some stuff in the past where it says WebM. So full screen. Again, this is one of those things that if you've ever been kind of a Flash developer, you've been able to say to HTML5 developers, I can take my content full screen. And the good thing is we can do that in HTML now. This demo here is basically saying this is a video element. There's a button that says go full screen. And we call the, we call the WebKit request full screen method. It fires an event that says, we've gone into full screen. But once this method here on the element is called, essentially the screen will go full screen. And this is kind of interesting because we say element, and the actual demo says body up there. Any HTML element can be made to go full screen. I mean, you could make a button go full screen. I don't know why you'd want to, but you could make a button go full screen. What do you reckon this demo does? Do you reckon it makes the button go full screen? No, it doesn't. It's actually a nicer demo. So the idea behind this is that we've got a video element. This is going to work great for video players. Whoa, this didn't work. 1 second. Right, cool, that's it. I was worried then for a second. This is just the div. This is the video element. Well, it's not really the video element. It's the div around the video element that we've made to go full screen. The reason why we've done that because we might want to provide a nice user interface around the video element. And here we are. That's it. It's full screen. It's playing the video. It's pretty cool. You can toggle full screen either through the keyboard or like a normal user gesture. So it's pretty nice. The other thing we can do as well is we can send iframes full screen. So let me just zoom in here. This content here is an iframe. All it says is, I'm a lame iframe. We toggle the content, and let me zoom out. We toggle the content, and actually it's got full screen frame content. That's actually pretty cool. We've made an iframe go full. Yes. Yeah. In Flash, you can't work on another window. Yeah. So the feedback was we can lock full screen. We can go full screen across multiple screens. We also can't detect what screen we're on. I believe that's the same in HTML as well. We don't quite know which screen that we're on at the time because it treats everything as a virtual screen, I think. Anyway, so the iframe side of things is kind of interesting because the content changed. It was the same iframe. We didn't reload the iframe data, but the content changed inside the page. This is kind of cool. I will show you why that works. If the browser itself at that time is hardware accelerated, it should all still be hardware accelerated. I don't believe we switch out. We have a JavaScript API to detect whether you are full screen or not. It's kind of interesting. Request full screen on any HTML element is kind of cool as well. Okay, I'm going to jump forward one slide because I want to show you one thing first before we go back. There are pseudo classes. Yes, sorry.
So in Flash, when it goes to full screen, it shows this warning that says there's escape before full screen.
Right.
That's primarily because people don't like mess up with the desktop and go show up phishing pages. Is there something that HTML5 also will show up eventually, or if the browser is going to go full screen without the user consent, I can pretty much show anything on the desktop?
Yeah. Okay. So if we jump back to the demo, right? Let me full screen API. Right, here we go. So the top part there's a unspoofable. Wait, it's not really unspoofable, but there's an area up there which allows you to basically say exit full screen or allow this actually to keep happening. The interesting thing is this is supposed to appear above any element that's kind of rendered in the browser, so you can't kind of go above it, which is kind of interesting. It's kind of cool. Exit full screen. Sorry, I went forward one. We have CSS selectors, so you can actually be able to style the content differently based off whether you can detect that you're in full screen mode or not. So you don't have to use a JavaScript API to then go and manipulate your interface. You also have to be able to say to an iframe, WebKit allow full screen. If you don't have that, an iframe can't go full screen. But once the iframe does, the demo that we had before was basically a pseudo prefix, or a pseudo selector, sorry, with a WebKit prefix that basically said, when you're in full screen mode, kind of display the HTML5 logos and some extra bits of text. So you get control over that. The interesting thing, if we jump back one, you can detect whether, this is actually new actually, you can detect whether the actual browser service will support full screen or not, so you can actually choose whether to let them even try and enter. CSS function, this is pretty new, and I've got a demo, and actually there's a bug in the demo, right, and I want to see if anyone notices this. But Crossfade's kind of interesting because, and I'll give you an example actually why it's kind of cool. When Google I/O last year, we built a framework called I/O Reader, like Google I/O Reader, which was basically just a news reading piece of software, which was like a news glide, so you can like page between articles, and they would dynamically load into the user interface, and it was kind of nice. But we needed to support low-res phones, tablets, desktops, and TVs, all in one code base. And we had to use hacks to basically say, well, we'd load a low-resolution image in first, and then once the image is loaded and we're kind of pretty sure that it's going to be able to load more data, we would load a high-resolution image over that. And the primary reason for that was because we wanted to deliver a low-resolution image on mobile, which is kind of interesting, because the high-resolution images were like, some of them were a meg in size, but they looked really nice. And the way that we did this was we had an image, the low resolution images, like image stretched to a particular size. And then we inserted a new image element on top of that that was completely transparent. And then once we detected it had loaded, we'd make the transparency from like, the opacity at least, from 0 to 1. So it basically replaced the image that was above it, and it kind of had a nice kind of smooth like load-in effect. It's kind of nice. It kind of looked really well, but it was a complete hack. It was like there was 2 image elements that we had on the screen at any one time. It wasn't kind of nice kind of DOM stuff. The idea behind this, it's a similar thing, but you can essentially load 2 images into an image element, or anything that's a background element at least, and then animate between from one to the next. So you can start off with the low resolution one, and once you're happy with that's loaded, kind of fade the new one in, and it's just essentially CSS. Rather than applying an extra image into the DOM, you have the one and load them in that way. It's kind of nice. It's a simple API. The demo is by Peter Beverley, one of my colleagues in London. The idea is that we have, let me zoom in. The first image, which is logobox.png to logobear.png. 0%, which means that the first image is fully shown and the second image is not shown. We go through to 50%. Here, 50%. Oh, sorry, scroll down, it says 50 to 100, which basically makes the foreground image and the background image, or the background image overlay the foreground one. So it's kind of nice, and it's just CSS, right? You don't need to have all these extra images in, so it's pretty cool. CSS filters is the next one. I actually added this slide in this morning because I managed to get it working in Chrome. Has anyone seen CSS filters? A couple of people. They're really nice, right? It might be in dev channel. It's enabled via an about flag inside Chrome. So if you want to start experimenting with it, you should be able to, one second, sorry, visit about, well, it's not really about flags anymore. It's changed its name. And search for filters. CSS filters, and you can enable it with GPU acceleration. This is really cool actually because you can now apply kind of blur effects to kind of pretty much any HTML element. Well, there's a bug in Chrome at the moment which means that you can't apply it to anything that's hardware accelerated, but that's going to get fixed. But the idea behind this, and I'll show you a demo because it's really nice. No. Right, that's a nice image, right? It's a normal image, just a normal image element, it's nothing special. We'll apply some blur to that. There's the image changing. Can we see that? It's kind of nice, right? And the theory behind this is it's just a CSS attribute, basically. You specify the filter, you can specify some blur on it. It's kind of nice. Internet Explorer has done some stuff for quite a while in the past with the DX filters. But now that we get this, it's pretty cool. So you can go grayscale, change the brightness a little bit. You know, you can keep applying them, change the contrast. It's pretty nice, right? It's pretty cool. You can also animate as well. So let me zoom in. So this is just animating the blur property on the WebKit filter. So you can do nice things. There's no code involved. It's all CS. Yes? Question?
Can you specify other types of things on the border?
I've never tried it, actually. I've only ever done pixels. Should we give it a go? Do you want to give it a go? Oh, sorry. I'm animating the blur. So if you've never used DevTools before, they're really good. So this is the image. Let's add an attribute on it. WebKit filter blur 1em. Yeah, you can. It's pretty cool, right? Yeah, so it's kind of nice, right? It looks kind of cool. You can apply really nice effects. We want to do some demos soon where things like in the foreground are nice and sharp, and then all the background items are kind of blurred out and things like that. So we want to try and do some really cool stuff there. Like I said, this is in Canary. This is the Canary build. It could be in dev, but it's one of those things. Is just try it on dev channel and see where it goes. If it doesn't work, it doesn't mean it's not supported. It just means it might be thinking that your deck or your element is hardware accelerated, which is a known bug at the moment. WebRTC is kind of interesting. The thing is like face-to-face communication inside the browser. We want to make that super simple. Has anyone ever used, what's it called? Chat roulette? Yeah, everyone says no, but I bet they have. So it's those type of things. You know, we don't want to have external plugins to be able to try and do, you know, these things that we want to try and do with people on the web. So you know, you connect to people, you talk to people. You can just connect straight through to a representative of the company. You know, those type of things that you want to try and be able to do. It should be possible inside the browser with a bit of, like, just a small piece of HTML and a small piece of JavaScript. Once it lands in more like a lot of other browsers as well, it's going to change the web. I think it's going to be absolutely awesome. There is a huge demand for it. You know, people want to be able to do this for a long time. You know, Chat Roulette was popular because it connected people. Well, you know, it was popular for a lot of reasons, right? But it connected people together, right? And that's really powerful. WebRTC itself is the idea. Like we said, it's a plugin-free peer-to-peer communication channel, basically. The theory behind this is that you as the developer, as the web developer, shouldn't have to do noise cancellation, buffer management, jitter management, all this kind of things, you know, which make, you know, communication hard, should be abstracted away, and you should just say, I want to connect to that person over there, and then you've got video-to-video communication or audio-to-audio communication. It's really powerful stuff. This is the obligatory architecture slide. Ignore it for now. It doesn't really matter that much. All it's saying is basically you as a developer interact with the web API. The web API interacts with kind of things like the peer connection, the video engine, the codecs, echo cancellation, noise cancellation, a whole load of things like that you shouldn't have to worry about. So we should do it. This is an example of what the code looks like from you as a JavaScript developer side of things. Let me zoom in. Peer connection is the interesting thing. It's this peer connection object which tries to make the connection through a centralized server, bust through the firewall like most of the kind of the Skypes and all the kind of video communication frameworks do, of the kind of the person who's participating on the same channel, and then connect you from that person to the other person. So the theory is, and we tested this because we were never quite sure whether there is an intermediate server that streams the video. You know, you send your video to one server and then the server sends it back out. We were never actually quite sure, and we did a test the other day where we had like a server running. We killed the server and the video communication still happened between the two parties. So it's kind of interesting. But this is the peer connection API. Stun, I don't know why, from a developer experience point of view, I have no idea why you need to put stun at the front. It just doesn't seem to make sense. But basically you initiate a peer connection with the server, and then you have an on-signaling message. It's basically a callback. Because in theory, you can send messages to kind of synchronize the clients behind the scenes through the peer connection API, so that you can send commands to all the participants to say, well, actually, you know, a video stream has been connected to this peer connection stream. You know, what do you want to do with that? You might not want to connect the video stream directly to a video object, like, you know, the video tag, so you can decide what to do inside JavaScript. And this is the code here. So whenever the onAdd stream event fires, you can basically say, take the stream, which is very similar to the, well, I say it's very similar, it's exactly the same as the get user media stream earlier on, for getting access to the video camera, and you attach it to a video object. So the thing here is that you just basically say, a new stream's come online, attach it to a video object, and then in theory you should have access to the person's, you know, the webcam that they're sending to you. So it's really nice, it's really cool. You as a developer, if you want to attach your video stream to the peer connection, get user media. Notice the difference here, video, audio, rather than the two flags. This is a bug in the slide. One of the slides is correct. I believe it's the other one, not this one. You get access to your local stream. You can add it to the video so that you can actually, you know, view yourself on the screen. But that same stream that you can then add it to the peer connection. So peer connection, add stream, your video stream, and then that's connected to the people who are also connected. So they will get the event saying, video camera added. You know, do you want to add that to the excuse me, do you want to add that to the video element so that you can start playing that? And that's pretty much it. Once it lands in more browsers, once it lands in the stable version of Chrome as well, there's going to be a whole load of applications that come off the back of this. Some are, well, break the dial paradigm. It's the worst phrase ever. But the idea is that you don't have numbers to connect people. You could have whatever constructs you have in your application, whether it's like Twitter names or whatever. You can start a call between, or video conference between those two people based off, say, a Twitter name. It's kind of cool. Build really social networks. That's kind of the Hangout thing, right? Is, you know, people want to talk to people and want to do it face to face. You could be able to do that with the WebRTC infrastructure. Online gaming, it's like party chat and those type of things. You're playing a game, say it's Angry Birds on the web, you just start to talk to people who are also playing the same game at the same time. It's pretty cool. Build cool baby monitors, yeah, maybe. But you could, right? I mean, you could literally put your Chromebook or whatever device that you have. I'm going to say Chromebook because I'm, you literally put that in the baby's bedroom, watch it, and then if it's on the same network, just kind of only stream them to your kind of device that you've got downstairs. So it's pretty cool. WebRTC.org is where kind of all the communications happening, the news groups are, the code examples, and the open source stuff. Obviously, code.webrtc is where the royalty-free license, BSD license code is. The theory is we've got support off Mozilla. I don't know how far along they are. I'm not saying it. I just don't know. I just don't know how far along they are. Opera, Google. Opera's got some really nice demos of interacting with the video camera, so I imagine they're not too far behind. But the idea is that we'll get this in loads of browsers, and it's going to be awesome, and we're going to build a whole load of really cool applications. How are we doing for time? Fine? Sweet. I'm getting towards the end anyway. So the WebAudio API. I spoke to some guys. Is there anyone from SoundCloud here? No? Okay. They're really cool. I think they're based in San Francisco and Berlin. Their idea is to make the web loud. You know, we've really suffered from having no ability to do anything cool with audio on a browser without plugins before. The WebAudio API is our idea of what we want to try and do on the web with audio. There are other competing specifications, and hopefully at some point they'll all be ironed out at the moment. But this is a kind of example of what happened in the olden days. You used to have background sound, play a MIDI file. That was pretty much it. You could then either use an embed or like an object tag with some flash. It was a bit crazy, right? Basically audio wasn't particularly native to the browser in the past. In theory, it should be. We introduced the HTML5, and the problem with the HTML5 audio is that it was probably overhyped a little bit. You know, the idea is that the audio tag solves all your audio needs inside the browser. It's one tag with some source files, and that's pretty much it. The interesting things that we've had is kind of some browsers that had different competing codecs, so we didn't have a consistent story across all the browsers. In Chrome especially, we didn't have an amazingly low latency kind of API. So you'd call play on the audio tag, and maybe 256 milliseconds later, the audio would play, which basically just ruins gamers' experience. So if you've got a game and you're trying to play some audio, you want like less than 20 seconds, like 20 seconds is terrible latency low 20-millisecond latency is kind of what you want to aim for, and we were kind of like an order of magnitude out. So you want kind of audio, like low latency, glitch-free kind of experience, and the audio tag just wasn't that. I know Internet Explorer has done a lot of work, and they've got a really low latency audio play API essentially with the audio tag, but quite a lot of browsers didn't. That's not all though. I mean, we want low latency. The thing that we actually want to be able to do is access the raw data that's playing either through an audio tag, so that we can apply effects to the audio that we want to play to the user in real time, right? We don't want to have to render different things on the server and kind of send them out. So we want to be able to do real-time audio processing and make it really cool. So you know, you can do things like echo. You could do echo cancellation in the browser. You could add echo to an audio tag. You could pan, kind of, you know, in stereo. You could pan pan the audio between the two sides. There's a whole load of things that you want to be able to do inside the browser and not have to resort to Flash. And that's what these WebAudio APIs are for. So the Mozilla API and the WebKit API as well. So this is it. So the main differences are, right, the similarities are we want to make it easy for you to be able to apply effects in a low latency manner way inside the browser and not have to resort to plugins or have to resort to basically trying to do things on the server, which is near impossible. The main difference is that the Mozilla one is all about the Java. You build the functions inside JavaScript to apply echo, maybe make it louder, quieter through gain kind of manipulation. What we try to do with the WebAudio API is provide them upfront so that you basically say, I need to apply gain to this audio source, and then you could adjust the kind of the loudness of the audio just by manipulating one value. The theory behind this is that we can take advantage of the underlying hardware to actually apply these effects. So if the hardware is, I know sound accelerator look like, you know, like a GPU, but SPU, I don't know, or the audio cards can accelerate kind of common functions at least. And that's the whole idea behind ours, is you don't have to do it in JavaScript. and have the browser render the audio, you can actually have the sound card go, well, you know what, we need to make this louder, make it louder. It's interesting because it's node-based. Sorry, yes? Raw samples from, yeah, it should be. And I've got a demo in a bit to actually hopefully show you that actually. So the question was, is there an API to access the raw sample data? Yeah. From like an MP3 file. Yeah. I'll show you in a bit actually, we've got a nice demo. It's a node-based system. That's not, unfortunately it's not Node.js, but it's basically you say there's an input data, like input node, which is like the source, an output node, which is the speaker, and you connect the source, the input to the output via, well, you just connect the two. You don't, I'm going to say like via a channel, but it's not. You connect the input to the output, which just basically plays audio. It's kind of cool. It's very simple. If you want to apply echo, you connect the input to an echo node, and then the echo node to the output, and then you press play, and it plays it with some echo. And I'm going to show you some demos actually. It's kind of cool. This is the interesting one. This is the, let me zoom in. This is the one that literally just plays some sound. Did it work? Oh, hang on. There we are, played some sound. Admittedly, it's a lot of code just to play some sound. I don't think you'd do it in most cases. You'd probably abstract that away inside some API. We can apply a delay of 2 seconds. There we are, it was 2 seconds. The way that we apply a delay is not via, say, set timeout to say do it in 2 seconds time. There is a source element or a source method called noteOn, which is, you give it the number of milliseconds to wait to play the sound. So it's kind of interesting. We can go loopy. Right, that's kind of interesting, right? It's not amazingly cool, just playing one little sound. It's not the greatest. However, we can do some really nice things. There we are, there's the play button, sorry. Here we are. So essentially, we've just made a method called play sound. We told it when to play on, so the note on. And because we've basically set this up in a series, literally it is just a series, we're not waiting for any extra stuff. We're saying that we should play at like an eighth of a note, 4 times eighth of a note is every 4 beats or whatever. So we can do all this and kind of queue up the sounds that we want to play, and then the sound card will go off and play them at that particular time that we've said to go and play them. So it's a kind of okay little API. We can do some nice things with that. The really cool thing, hopefully this demo will work. It took me ages to actually work out what this demo was doing. Let me load it, Bohemian Rhapsody. Okay, let me just load it up. I'm going to come back to this one. Oh no, oh, wow, it's crazy. So the idea behind this is you can just click on things, just taking samples of stuff. The interesting thing is that you can sort by a whole lot of different values. So we sort by loudness. That's the loudest part of that song. It's kind of cool. Yeah, it's the quietest one. It is that quiet. It's kind of crazy, but you've got the different bits in between. The reason why this kind of works is that they've been able to analyze the sound, and you can do some kind of like client-side manipulation, and then break that up into chunks, and then decide to play that individual chunk. So it's kind of nice, nice little demo. We can do crossfade. This is kind of interesting. I'll show you the code in a second, but it's an organ. And we get drums in the background, so we can do some kind of. I should actually quiet it down before I speak. So we can kind of basically do some nice things with this. The reason why this works is not because it's kind of dual channel in a way, but essentially what we've got is we've got 2 buffers, sound buffers playing at the same time, and then we adjust the volume between both of them. And we adjust the volume through this idea of a gain node. So essentially, I'll show you actually what we're doing here. Actually, we're saying we're connecting the source. The source is the MP3 file or whatever file that we're playing at the time. We connect it through the gain node. So a gain is like the volume adjust. And after that, essentially, so the destination of the context, the audio context itself, is the speaker. So basically, we've said the source input is connected to the gain manipulation, so we can adjust the volume programmatically. And then that output is connected to the speaker. And that's all it does, really. Let me show you the code. There we are. sorry, here we are. Here we are. So I didn't actually do this demo. My colleague Eric Bardelman did this demo. But essentially, I initially thought you'd scale it down kind of like inversely proportional to the, you know, one's at 1, one's at 0, and then one's at like half, like half the volume, the other's at half the volume. It doesn't exactly work that way, but essentially this is how he's adjusted the gain. So he's got an algorithm which basically adjusts the kind of the volume for each channel, each sound that's playing at the time. But that's pretty much it, right? You have the ability to basically adjust the values on each of these nodes to essentially adjust what's played back. So the really cool thing as well is because obviously we can play sound, we can play it from the browser, from like MP3 files and all that type of stuff. We can also generate sound on the client as well, which is kind of nice. We've never really been able to do that so much. It's been really hard to like generate an MP3 file and then attach it to an audio file, the audio source attribute on the audio element. We can now just generate the data as a normal waveform and pass it through the WebAudio API. So we've got the ability to, sorry, it's kind of loud, play a sine wave. We can then do a triangle wave. That one hurts. Yep. So it's kind of cool, right? We can actually generate the audio on the client and pass it through to the generate the audio on the client and pass it through to the audio subsystem and kind of do whatever we want with that. Then it's kind of pretty cool. It's pretty nice as well. So this is just basically this code at the top is generating the sine wave. We've created a buffer source, and the buffer is based off the data essentially. So we're creating a buffer, setting the channel to the value of the sine wave, and then we just play it, and we play it in a loop. So it just generates one kind of arc or one wave of data, and then just keeps playing that over and over again. It's pretty nice. It's kind of pretty cool that we can actually generate this information on the client. I'm not going to show that demo. It didn't work. So the real-time audio processing is kind of cool, which hopefully gets to the point that you raised before. The idea behind this is that this is a node-based system. So you connect like an echo node up to the to the MP3 file, and then you connect that echo to the speaker, and then you play with echo. The interesting thing is that you can connect an analyzer node. The analyzer node essentially is a piece of JavaScript which actually gets you raw access to the data that's being played at the time. And this is it. So we create the buffer source, we connect the buffer to an analyzer. The analyzer essentially is this piece of code here. So you can get kind of byte frequency data and a whole load of other stuff. So if you were saying it's a compressed file before, it decompresses it to play it, it passes it through your analyzer node so you can actually get the frequency information back out. So it's pretty cool, and you can do some nice things. Was anyone at I/O last year? One person? Cool. So this is hopefully new. So this is a demo that we had at I/O. It's not playing just yet. Right. When it loads, it'll be really cool. Let me just try again. Right, so you're going to have to play with me here, right? Right, so this is HAL. It's obviously a computer. The idea behind this was that the audio was playing at the time. We pass it through the analyzer node. Because we can get access to the raw data, we can manipulate the red kind of beam in the middle, so we can make it like smaller and larger, so it looks like it's talking to us based off the frequency data. It's a really nice demo. I'm not sure why it's not working though. It worked in the office. Yeah, because normally it's a play button. That works quite nicely. But that's kind of the interesting thing is because we have access to this information, we can do a whole load of really nice kind of things on the APIs then. So it's kind of really cool. This is new. I don't actually have a demo for this. But the idea is that you might want to apply some effects and actually record the output. So you don't want to be able to just say, well, we're going to play the data and it's going to play through the speakers and play it for 20 seconds. The idea behind this is the processing offline mode is that you can basically construct this node kind of like this node sequence to apply effects to your audio. The idea is like you want to apply 20 seconds of echo effect to an audio sample without it going through to the speakers. You can use this kind of part of the API. You create the WebKit audio context. You tell it how long it's going to be for. And then there's a function at the bottom when you start playing called start rendering. And the name implies basically you're rendering the audio to basically like an output file. You get an onComplete method. And once it's complete, you can get access to the rendered data, which should be the audio file that you can then upload to your server to go and do some nice things with that. So that's a nice thing. I believe it's in Canary, but I've not been able to test it, and I haven't got a proper demo that works at the moment. But it's coming soon, and it's going to enable a whole lot of different types of applications. It's kind of nice. The interesting thing is that we've now got integration as well with the audio element, so that your input source can be the audio tag. And the thing that I'm hoping with this is that you have an audio tag, you connect an analyzer node to the audio tag, and then you can do some really cool stuff with that. I'd like to be able to connect this audio data. I don't know whether it's going to work just yet, but I'd like to be able to connect this audio data to, say, the WebRTC, like the WebRTC stack, so you could play some audio on your side, push it over the peer connection, and then people on the other side would be able to hear it as well. So it'd be kind of nice if we can do that. But the idea behind this is you've got audio files. The audio tag knows how to load the data nicely. You can have it in the user interface, but then you can apply effects to that data that's already in the tag. Likewise with an audio video stream as well. And luckily, I'm right now at the end of the presentation. Yeah, thank you very much.